All right, so 4.7 antiderivatives. Antidifferentiation is the process of recovering a function from its derivative, or you can look at it as being the undoing of the differentiation of a function. All right.
If you don't mind me asking,
Mhm.
what section did you cover on Monday?
Just 4, 4.
Okay, cool.
Yeah. All right, so if f is an antiderivative of lowercase f, which is f on the interval I, then the most general antiderivative of f on that interval I is f of x plus c. And the main thing that we point out here is that if you don't have any initial conditions, then you have to use that plus c, because c is going to represent any arbitrary constant. So remember, when you take the derivative of a constant, it goes to 0. So when you take it back or try to find the antiderivative, you don't know what constant that could have been there. So that's why you have to leave c as an arbitrary constant. So unless they give you some kind of initial condition, and you'll see what I mean as we go through a few examples, you won't know what c is, or you won't know what type of constant, what number could have been there. So just quick example, look at f of x as being 5x. Nope, let's just go x to the fifth plus, let's go 7. So if I have f of x is equal to x to the fifth plus 7, the derivative of f of x is 5x to the fourth. So now remember, the antiderivative is taking this back to this. But if I have 5x to the fourth, there's no way for me to know that there was a plus 7 in my original function unless I'm given some initial conditions. So when we go and actually do the antiderivative, that will go to x to the fifth plus c, because I don't know and I don't have a clue about this 7 unless they give me something. And so some problems will give us something, some of them will just tell us to find the general um, antiderivative. All right. Let's look at some antiderivative formulas. And I believe I gave these to you guys like close to the beginning of class when I gave you a bunch of derivative formulas. I think I gave you antiderivatives as well. I'll check that email, see what I gave you. Let me write that better. All right, first two, if you have x to the n or the nth power and you want to find the antiderivative of that, that'll be 1 over n plus 1 times x to the n plus 1, and that's plus c. So that's the reversal of the derivative process. You know, if you were taking the derivative, you would bring down your exponent and then subtract 1 from it. So this is just giving an account for that process. Then sine of k times x is negative 1 over k cosine of k times x. Cosine of k times x. 1 over k sine of k times x. And all of those notes will have plus c at the back because they're the general antiderivatives. And these are the more straightforward antiderivatives. There are ones that call for more, that are more complicated and more involved. So we have secant squared of kx is equal to 1 over k tan k times x, or tan of kx plus c. Then cosecant squared of kx is negative 1 over k cotangent of kx plus c. And here we have secant of kx times tan of kx. That's going to be 1 over k secant of kx plus c. And then the last one that they give, cosecant of kx times cotangent of kx is equal to negative 1 over k cosecant of kx plus c. So they give us 7 general antiderivatives. All right. Let me do this. All right, so let's look at the first one. It wants to find the general antiderivative of f of x is equal to x to the 7th power. So they represent that with capital F. And so that'll be 1 over 7 plus 1, x to the 7 plus 1 plus c. So it's 1 over 8, x to the 8th plus c as the general derivative. General antiderivative, excuse me. So if I were to take the derivative of this, then I'll be bringing the 8 down. 8 over 8 will cancel out to give me 1s. And then subtract 1 from that 8 from my exponent. It will give me x to the 7th. And then if this is a constant, the derivative of any constant goes to 0. So I'll be left with just the x to the 7th power. All right. G to the x equal to 1 over the square root of x. All right. What I would do is rewrite this as 1 over x to the 1/2, which also is x to the negative 1/2. It's going to be capital G. So, following the formula, that's 1 over negative 1/2 plus 1. That's x going to the negative 1/2 plus 1. Plus c. Negative 1/2 plus 1 is positive 1/2. And then 1 divided by 1/2 is 2. So you either have 2 x to the 1/2 or 2 square root of x. Either way, plus c, of course. Either way, those would be answers. Any questions? Any questions? Like I said, we're just undoing the derivative process. Things like this will help, when we talk about our physics. Remember before we were going from position, your s to velocity, derivative of s, to acceleration, which is the derivative of your velocity, or the second derivative of your position. So if you had your acceleration, take the antiderivative of that brings you down to your velocity. Take the antiderivative of your velocity, it takes you back to your position formula. So, being able to go forward with your derivative process or backwards with your antiderivative process most definitely would be beneficial for you to know. So looking at the derivative or the antiderivative of sine of 2x, so we're looking at, they call it capital H. And so if you go back to your formula, what's sitting in front of your x is considered your k. So it's going to be negative 1 over 2 cosine 2x plus c. Yep, and that's all there is to that one. Let's see, do we have I guess we can do that one. Next one is dealing with cosine. We call it function I. Okay, yeah. I'm going to rewrite that in red to try to stay consistent. notes just in case. Yeah. All right, so same thing happens here. This is going to be 1 over 1/2. You know, that is cosine of 1/2 x. Same thing. X over 2 is 1/2 x. And that's going to be sine of x over 2 plus c. 1 divided by 1 over 2 is 2. Oh, let me go back and do this one. Questions on anything?
No, it's a lot easier. I was looking at it first, like I don't know what's going on here, but the light bulb went off. So
Sounds good. Sounds good. Sometimes, that's all it's about. Once the light bulb go off, then we'll cut on whichever way you want to say it. Yeah. Then it's smooth sailing. Okay. So it says find the antiderivative of f of x equal to 3x squared. That satisfies your original function to be f of 1 equal to -1. So when you plug 1 in, you get out -1. So the first thing we want to do is apply the antiderivative. So we leave that 3 on the outside. And that'll be 1 over 2 plus 1, x to the 2 plus 1. So that's 3 times 1 over 3, x to the third, and that's plus c. So the 3 and the 1 over 3 cancels, leaving you with x cubed plus c. So this is your capital f of x. So now we have to use this initial condition. Matter of fact, let me use another color. It says that when you plug in +1 to the function, you get out -1. So I need to solve this for c. 1 cubed is +1. Then go ahead and subtract 1 from both sides. And that leaves you with c equal to -2. All right, so to finish it off, x cubed minus 2 is your answer. So the only times you can substitute in something for c is when you have that initial condition, letting you know that when you plug in a number into that derivative, you get something else. And they tell you what that is. All right, questions. All right, so indefinite integrals, the collection of all antiderivatives of f, is called the indefinite integral of f with respect to x, and is denoted by this notation right here. All right, this symbol right here, I drew it the best way I could. You'll know when you see it in the book. This symbol is the integral sign. Lets you know to take the antiderivative of your function. The function f is the integrand of the integral, and x is the variable of integration. So if you were taking well, they wouldn't ask you, or they wouldn't have to ask you. All they could say is fine, and they expect you to know the symbolism. So this is the integral of 2x with respect to x. That'll just be x squared plus c. Yeah. If you were to go through the formula, matter of fact, if I can get it to erase, there we go. You got 1 over 1 plus 1. Whoa, I gotta leave my 2 out there. Leave the 2 out there. 1 over 1 plus 1, x to the 1 plus 1 plus c. So that's 2 times 1 over 2, x to the second power plus c. The 2 and the 1 over 2 will cancel and leave you x squared plus c. And so, of course, the more you do these, the less it becomes that much of a process. And it's not as much of a S as I'm making it. I just can't draw it the way the book has it. All right, so we have the integral of x squared minus 2x plus 5. All right. So what we can do is take the integral of each one of them individually, just like you can do derivatives. All right. Doing it individually for each. That's 2 plus 1 down here. X to the 2 plus 1. Minus, you got 2 on the outside. 1 plus 1, x to the 1 plus 1. We got 5 on the outside. And if you think about it, right here, that's the same thing as x to the 0 power. So what we're looking at is 0 plus 1, x to the 0 plus 1. And all of that, of course, you add your c because you have the general derivative. A lot of this stuff, the more you do it, especially like when you look at a constant, you'll automatically know that's just going to be 5x. So if you were taking it with respect to y, that'll just be 5y. But like I said, we're just going through the process right now to make sure we're okay with what's going on. So that's 1/3 x to the third minus 2 1/2 x squared plus 5 1 over 1 x to the 1 plus c. All right, so to finish it off, 1/3 x to the third. 2's cancel. Leave me with x squared. And then that's 5x plus c. All right, questions.
No, sir.
All right, let me see if I can find. Do at least one more. That was the end of that section. All right. All right, so let's go ahead and do this one. The x to the x 1 over x squared. I will write that as x to the negative second. Now we can take the antiderivative of each one of them individually. It's negative 2 plus 1, x to the negative 2 plus 1, minus 1 over 2 plus 1, x to the 2 plus 1, minus, and since 1/3 was a constant, we can just go ahead and put an x back there. That's the same thing that happened with our 5. We had a 5 as a constant. That ended up just being x for us. So you can follow that same thought process. Plus c. So 1 over negative 1, x to the negative 1, minus 1 over 3, x to the third, minus 1/3 x plus c. And we can finish off the simplification as negative 1 over x minus 1 over 3 x cubed minus 1/3 x plus c. Let's see, cosecant. All right. Let's do another one. Cosecant theta. I put cosine. Cosecant theta. Cotangent theta over 2 with respect to theta. So I would bring that 1/2 out front, just so I'm looking at this. And don't forget, we have, I guess I'll write it right here. I guess I could have put K there. Let me do it like this. All right, so just leaning on that relationship, cosecant kx times cotangent of kx is equal to -1 over k cosecant kx plus c. So k in this case is 1. So we really don't have to worry about that. So that's going to be 1/2 times -1 over 1 cosecant of theta plus c. So it's -1/2 cosecant theta plus c. So just following the formulas properly. Do this last one unless you decide you want more. All right, so we have 2x times 1 minus x to the -3rd dx. The antiderivative of that. So what I would do is distribute. So I can just take the antiderivative of each one of my terms individually. So I'm looking at 2x and then 2x times x to the -3rd. Don't forget, whenever you're multiplying like variables, you're adding your exponents. So that's the one up there. So it's going to be 2x minus 2x to the -2nd power. So from there, we can apply the antiderivative to each term individually now. That's 2 times 1. Oh, yep, I'm good. 1 plus 1. X to the 1 plus 1 minus 2 times 1 over -2 plus 1. X to the -2 plus 1. That's plus c. That's 1/2 x squared minus 2 over 1 over -1, times 1 over -1, x to the -1 plus c. 2's cancel. So that's just x squared. And negative to a negative turns positive, so that's plus 2 x to the -1st plus c. So finish it off. I might bring the x down bottom and write it this way. But that one's actually fine as well. So it just depends on how the book want to see the answer. All right. Questions? Any questions?
No, sir.
All right, sounds good. So I need to post some homework. I think I'm a little behind on posting. If I'm not mistaken, because I meant to post some Monday and I didn't do so. So need to get that up there. I know you guys can't wait to get to that. So, so
Are there still other people in the class?
yeah, they actually. It's funny. They actually showed up last class. You know,
The
so
chances. The chances.
right, exactly. I was like, well, are they doing this on purpose? I was like, wow. And then for you to show up and then they not show up again today, I'm just like, they got to be coordinating this. So, but yeah, two of them showed up last class, and the other one, she's still doing her work. I think what she's doing is just looking at the videos. You know,
Alrighty
so
then. I mean, I thought I'd ask because I haven't seen him on here in a while.
yeah, and that's why I say it's just funny that you guys are just alternating, alternating days. But it's crazy because you come like back to back to back to back, and then the one day you miss, that's when they show. So
Yeah, the only day that I've missed.
right.
Yeah.
But yeah, everybody's still in here trying to knock this stuff out, man. So, but yep. So always feel free to hit me up and I'll ask questions if you have them. Have a great weekend, and I'll see you on Monday.
All right. Are you gonna be emailing the 4.4? I imagine you recorded that too.
Yes, I'll shoot. Hopefully, I can get it done tonight. If not, it'll be tomorrow morning.
All right. Cool beans.
All right,
Thank
man.
you.
Yep. Have a good one.